Hello and welcome to the lecture on plant hormones. It's going to be a very important lecture, and it is our last lecture in the plant series. There are going to be 6 plant hormones that we'll be looking at today: auxin, gibberellins, abscisic acid, not even going to try and pronounce it, ethylene, and a couple more. So let's start off with auxin. The effects of auxin is that it controls cell division and differentiation. It is based off, and it is the hormone that is used in phototropism. Now remember back to your reading, photo means light, tropism is movement. So it's the movement towards or away from light. And this is because of the asymmetrical distribution of auxin. So the cell's on the darker side, and if we look at this image to work along with it, here we zoomed in. On the darker side, you're going to have a greater amount of auxin because that's going to cause the cells on the darker side to grow, thereby bending the plant towards the light. It is also important in apical dominance. Remember, apical is referring to our auxiliary buds and our meristem tissue that allows the plant to actually grow. Next up, we've got gibberellins. And gibberellins are a family of hormones with over 100 of them that we currently know of, and the effects are stem elongation. So these are really important in fruit and plant growth. So here you're seeing a seed. This stem growth that you're seeing happening is because of your gibberellins. And normally when you see your grapes in the store, for example, the guys on the right are a lot plumper, they're a lot juicier. That's because they've been treated with gibberellins that have helped their stems grow. And if you have a bigger stem, that means you have access to more water and nutrients, allowing the fruit itself to grow to a larger size. This also plays a role in seed germination, allowing the stem of a new seed to grow out. Next, we've got ABA, which is the acid that I cannot pronounce. And the effects are that it slows growth, and it also allows the seeds to become dormant, which ends up being very important, especially if the environment is not actually healthy and conducive for a new plant to grow. So high concentrations of ABA leads to non-germination. And the only time you can have germination is once the ABA is inactivated or it's leached out, which means it is sucked out. And this survival value is what I was talking about. The seed will only germinate in optimal conditions, and while the conditions are not optimal, you have high levels of ABA because that's keeping the seed dormant. And by optimal conditions, we mean, of course, you need to have the right amount of light, the right temperature, the right moisture, the right nutrients in the ground, etc., etc. Next up, we've got ethylene, and this is probably the one that you guys have the most real-life experience with. Ethylene is a gas released by plant cells, and the effects of it are to cause fruit to ripen. It also causes leaves to drop, like you see in the autumn. So the leaf drop is very important because the moment one leaf starts to release it, it's a gas, and this diffuses over to the other leaves, thereby stimulating them to start getting ready to drop and eventually drop as well. As far as the fruit ripening goes, this is very important because if I've got a full bunch of bananas and one of them starts to release ethylene and starts to ripen, it's going to send this gas over to the other bananas as well, causing them to ripen along with them. This can also lead to some apoptosis. That's when the fruit or the leaf is finally dropping, or the fruit is becoming rotted. So when every fruit's got a period where it's extremely ripe, it's very juicy, very sweet, but after a certain point, it starts to die and rot. Right? And that is why one bad apple can spoil the whole bunch, because one guy starts turning bad, starts releasing high levels of ethylene, thereby causing the rest of the apples in the bunch to start rotting as well. Now the fruit ripening, the ethylene, is actually an adaptation by our plants. Hard, tart fruit, so this is before they have ripened, this ends up being a deterrent for herbivores to come eat them. However, as it ripens, the fruit turns very sweet, it turns very soft, very juicy, and this is to attract animals to come eat that fruit. Because what these animals are going to do is they're going to take this fruit, they'll digest the main part of the fruit, but the seeds inside the fruit will then be released when the animal defecates. As part of its feces will start to decompose, thereby providing the starting nutrients for a plant. And this is just talking about the positive feedback system. And that's talking about how ethylene leads to the production of more ethylene, which leads to the production of more ethylene, thereby feeding upon itself. Now, apoptosis in plants is very, very important because it's actually what causes certain parts of the plant to die in a controlled fashion, as you see in the fall when plants turn color and they start to fall off. This is a response to the hormones in the plant, especially ethylene and auxin. And the death of an annual plant sometimes happens after it flowers. Now, why is this important for an evolutionary standpoint? Well, the reason is because during the winter time, there are a lot less nutrients, water available to the plant. So during that low period, the plant doesn't want to support hundreds of leaves. So it's better off dropping those leaves off and supporting just the main stem and trunk of the plant. And then when springtime returns, it can go ahead and regrow those leaves. That also gives it access to fresh tissue. So that is very important. So if you have any questions, please, you know where to email me, call me, or text me, and I will love to answer them.